Thanks for watching. And today I would like to talk about the law of sines, which is a very neat way of calculating the sides and the angles of a triangle in case you don't have a right triangle. And in fact, let me motivate this with the following. Suppose you do have a right triangle. Then what is sine of an angle theta? Well, remember, sine of theta is opposite over hypotenuse. So just to reiterate, sine of this angle is the side of the side that this angle is facing, so opposite, over hypotenuse. So almost think of it as a flashlight. So you have this angle that's a light, and then which wall is this light flashing to? Now, it turns out if you don't have a right triangle, you still have a similar formula. And in fact, let me first show you an example. Suppose you have the following triangle. This is 33 degrees, and then this side is 6.7, and this angle is 65 degrees. Now, the law of sines, you always have to think of it as follows. So law of sines. I'm not going to use letters, that's very confusing, but it's always opposite over sine of an angle equals opposite over sine of an angle equals opposite over sine of an angle. And no, it's not like Beetlejuice, Beetlejuice, Beetlejuice. The reason I write it as follows is, whenever you take an angle, then the opposite side divided by the sine of this angle equals, for the other angle, opposite side divided by sine of this angle, which equals to the third angle, opposite side divided by sine of the third angle. So in this case, let's see what we have. So again, we have this triangle. Again, 33 degrees. What was it? 65 degrees. And then 6.7. So let's first of all try to figure out this side. Okay. Well, what does this formula say? It says that, let's say for this angle, the opposite side is 6.7. So 6.7 divided by sine of this angle, so sine of 33, equals this side divided by sine of 65. And you see, now that you cross multiply, you can actually figure out what this question mark is. Namely, question mark, again, this side is just 6.7 times sine of 65 over sine of 33. And I believe you get roughly 11.1. So now we can complete this triangle. So again, we had, this was 6.7, this was 33, this was 65, and this was, again, roughly 11.1. And well, let's still try to figure out this angle and then this side. Well, in order to figure out this angle, there's not much math needed, because remember, the sum of the angles of the triangle is 180. So this angle is just 180 minus 65 minus 33, which gives you 82, I believe. So this angle is 82. And lastly, to figure out this side, again, you use the law of sines. And again, you can use whichever side you want. So how about we use this angle? So this angle, the opposite side is 6.7. So 6.7 divided by sine of 33 equals, again, this side divided by this angle. So question mark divided by sine of 82. And again, just like the analogy I said, suppose how do you figure out what the opposite side is? So think of this as a flashlight. Then what side is it flashing? Well, this one. So that's a 6.7 divided by sine of 33. What about this side? Well, think of it as a flashlight. It's facing this side. So this side divided by sine of 82. And then you can again just cross multiply and solve for question mark. So question mark becomes 6.7 times sine of 82 divided by sine of 33. And that's roughly at 12.2. So in the end, what we get the following triangle. So we have this side was, this angle was 33, this was 65, this we found 82, and then this side was 6.7, this is roughly 11.1, and that's roughly 12.2. So you see, the law of sines is very useful once we know an angle of a triangle and we know some of its sides. So now let's do another example. And unfortunately, this situation does become a little bit trickier, but not so much trickier because it's always the same formula. So suppose you have this triangle. This angle is 50. This is 5.6. This is 7.4. And we want to figure out this angle. So again, just use the formula. Opposite over sine of angle equals opposite over sine of angle. So if you start with this angle 50, it's flashing the wall 5.6. So 5.6 divided by sine of 50 equals, so this one is flashing this wall, 7.4 over sine of question mark. And again, you can cross multiply and you find sine of, or if you want 5.6, sine of question mark equals 7.4 times sine of 50. And therefore, sine of question mark equals 7.4 sine of 50 divided by 5.6. But we do have a little problem, because then we get sine of question mark equals 1.01. How is that possible? Because, again, what's the issue? The problem is sine of an angle is always between -1 and 1. So how can it be equal to 1.01? It turns out this is impossible. And it turns out in this case, we have no solution, which just means such a triangle doesn't exist. Just like, for instance, a triangle with sides 8, 2, and 1. It cannot be a triangle because those sides are too small to get the side of 8. Same thing here. There's no triangle with the angle 55 and sides 5.6 and 7.4. So beware, sometimes there's no solution. And even worse, sometimes there could or could not be many solutions. So now how about the following triangle? This is 13, this is 70 degrees and 10.5, and we want to find out this angle. Then again, law of sines. Opposite over sine of angle equals opposite over sine of angles. It's almost like billiards. This over this equals this over this. So again, let me erase that. So again, opposite over sine of angle. So 13 over sine of 70 equals 10.5 over sine of this angle, question mark. And again, you cross multiply. 13 sine of question mark equals 10.5 times sine of 70. And then sine of question mark equals 10.5 sine of 70 over 13. So sine of question mark is roughly let's see, 0.759. Well, and what you know about inverse trig functions, you could conclude that question mark equals arc sine, approximately equals to arc sine 0.759. So the point is, if you put sine on the other side, you have to put this minus one. And this is roughly equal to 49 degrees. And by the way, I don't know if I told you this already, but make sure your calculator is in degrees, not radians, for those kind of problems. So what did we find? We found that question mark is 49 degrees, but you have to be a little bit careful because think of this, we found that sine of question mark is 0.759. It turns out there could be another angle, and let me show you why. Again, remember your trig circle, okay? And we said that we want to look at the angle whose sine, let me draw this better, whose sine is 0.759. Well, we found this angle, which is 49 degrees. Okay? However, look, there's another angle with the same property, which is this one. Well, how can we get this angle? So this big angle actually. Well, notice it's 180 degrees minus this angle. But this angle, well, it has the same angle. So really to get this angle here, all it is just 180 degrees, which is the half circle, minus 49, and which becomes 131 degrees. So be super careful in those problems for the law of sines. If you find sine of something equals to a valid number, then the answer is either arc sine or 180 minus arc sine. So there are two possible angles, 49 degrees and 131 degrees. And what you need to do is to check if either of them is correct, because it turns out sometimes there's an outlier. So an angle that looks correct but isn't. Let me explain what I mean. Because now we have two possible scenarios. So remember our configuration, this was 13, this was 70, okay? And this was, I believe, 10.5. Okay? And this is, again, 13, 70, and this was 10.5. All right. And again, our goal was, I believe, to find, let's see, the goal is to find this angle, first of all. Okay. And we actually found it. We found two possible scenarios. One was, let's see, one was 49 degrees, and the other one is 131 degrees. And the question is, does this make sense? To check if it makes sense, you just need to calculate this last angle and see if you get an answer, basically. Because if you calculate this angle, well, the sum of the angles of a triangle is 180. So that's 180 minus 49 minus 70, which is 61. So this triangle actually makes sense. It has angles 49, 61, and 70. What about this one? Well, it would be 180 minus 131 minus 70, but that would give you, I believe, minus 21. So could this angle possibly be minus 21? No, it doesn't make sense. Here the angles are between 0 and 180 degrees. So it turns out this second choice is actually wrong in this scenario. And all we need to do is focus on the other choice. And I guess in this problem, the question was find the last side. Well, now we can just use the law of sines again, because what do we have? Again, opposite over sine of your angle. So 13 over sine of 70 equals opposite over sine of 61. And then we can just cross multiply. So question mark equals 13 sine of 61 over sine of 70. And that gives you roughly 12.1, I believe. So in fact, we have our correct triangle at the end. Namely, this angle of 61, 70, and 49. And the sides are 13, 10.5, and 12.1. Very, very neat. So again, just to recap this problem, because this is a little bit harder. So suppose, where was I? Suppose you have this triangle, and first you're trying to figure out this angle. Then you do, again, opposite over sine of angle equals opposite over sine of angle. And then basically you find this equation, sine of something is roughly 0.759. Then you have to be careful. The answer is either arcsine of this value or 180 minus arcsine, which here we give 131. And then you just need to make sure if those answers make sense. In order to check if it makes sense, check for the last angle. Here, if we calculate the last angle, we get 61, which makes sense. It's between 0 and 180. But here we get minus 21, which doesn't make sense. Angles are not negative in this problem. So we exclude the second one because it doesn't make sense. But this one does make sense. So we just calculate the last side by just, again, using our law of sines again. Good. And last but not least, I want to show you, well, sometimes both cases make sense. And in fact, let me find the problem. So example 4. Suppose you have the following triangle. So with sides, let's see, 8, 9.3, and 44. Again, if you want another example of this. And let's first of all figure out this angle. And again, we know that because we have opposite, angle opposite, and then this angle. So let's apply the law of sines. Again, opposite, which is 8, over sine of 44. Again, remember the flashlight analogy. This is flashing this wall, and it equals 9.3 over sine of question mark. And then cross multiply. So 8 sine of question mark equals 9.3 sine of 44. And then you get sine of question mark equals 9.3 sine of 44 divided by 8. And that gives you sine of question mark is roughly 0.81. And first of all, it does make sense. It's between -1 and 1. So definitely there is a solution. One of which being question mark is arcsine of 0.81, which is roughly 54 degrees. But remember, there's this other choice, which is 180 minus that. Remember this trig circle analogy, or 180 minus 54, which is 126, which again gives us two possible scenarios. Again, our original sides, angles and sides were 44, 8, 9.3. And now we found this angle is 54, or it's 126. By the way, this is not drawn to scale. 126 doesn't look that tiny, but again, here's just a model. So I get 9.3 and then 8. And remember, sanity check. We need to check if this last angle makes sense. Well, Here we need to do 180 minus 54 minus 44, and that's 82. So this one makes sense. And we need to check for this angle. So 180 minus 126 minus 44, which is 10. So you see, this one also makes sense. And lastly, we can just calculate those sides. So again, just choose the original one in case we made a mistake. So opposite over sine of the angle equals opposite over sine of the angle, because this angle is flashing this side. So question mark over sine of 82. So question mark becomes 8 sine of 82 over sine of 44. I hope it's a good sign. Okay, so question mark becomes roughly 11.4. Okay? Whereas for the other scenario, again, you do the same thing, but with 10. So 8 over sine of 44 equals question mark over sine of 10. So same spiel as before, so question mark, that gives you 8 sine of 10 over sine of 44. And that should give you, let's see, so 8, actually 1.999 something, which in the end gives us the following triangles. So two scenarios. Either we have this triangle, and that triangle had, angle 44, side 8, side 9.3. This we calculated to be 54, one of the choices, which gives the other angle of 82, and this side 11.4. Or we had the other scenario. So again, this was 8, 44, 9.3. The other choice was the angle of 126, which gave the other angle of 10, and this side too. So the moral of the story is, for this law of sines, there could be no solutions. And that would happen if here you find a number either bigger than 1 or less than -1. There could be one solution if one of those triangles doesn't work out. Usually means this angle is negative, or maybe bigger than 180 degrees. Or there could be there could be two solutions, which is in this case where there's two possibilities. So as I say, c'est la vie. This is life. This could happen. All right, I hope you like this. And if you want to see more math, please make sure to subscribe to